Hello everyone, today we have an unusual video. This is a tutorial lesson. I have long wanted to explain how video surveillance codecs work, and video in general. But some animation was needed. We will now try to use my own animation to talk about different codecs. Let's go. So, video surveillance, when it appeared in the format we are familiar with, was recorded in the MJPEG codec. What is the MJPEG codec? Surely you have all encountered photography. And most often, photographs are stored in the JPEG format. Motion JPEG is simply 25 JPEG format photos per second. Surely you've all seen how animation is made, how cartoons were made in the past when they used a notebook, flipped through it. And to get a short 10-second video, it required a huge amount of paper and drawings. JPEG and MJPEG. Motion JPEG worked exactly like that. That is, it was necessary to obtain a huge number of shots, essentially like from a camera, and arrange them in a sequence. Such video was very heavy, and it didn't satisfy anyone. Neither the hosts who stored this video, nor the various streaming services that transmitted cable television. And of course, it didn't satisfy the field of video surveillance. And then, using a certain mathematical knowledge, the H.264 standard was developed. Surely you've all seen it and know it. What was its feature? First of all, this codec was, as claimed, was 10 times lighter. But how did this happen? This codec worked as follows. We have the first frame. The system takes a picture of what is happening around. Let's say there's a little tree there, and a person is walking, moving. In a regular MJPEG codec, to get 1 second of video, we would need a huge number of such shots. But in the H.264 codec, a mathematical model was devised, raising the question, do we need to transmit the entire frame in full? Wouldn't it be better to transmit only what actually changed in the frame? After all, if everything else didn't change, we can inform the system about it. That is, in this case, for example, only the person changes. Why should we transmit the rest of the frame? Then this frame was called a reference frame. It is the frame relative to which all changes occur. And the system says, I will only transmit the person, as everything else in the frame is not moving. And such additions occur 25 times. If the image in the frame changes drastically, then of course the reference frame changes. But typically we receive 1 reference frame per second and 24 so-called additions, which significantly reduced the data volume. That is, we achieved a 10-fold reduction in volume. And that's cool. But technology, once again, does not stand still. And our cameras were increasing in resolution, with more and more cameras, and all of this needs to be stored. And for those services, that provide streaming video, these problems are even greater. They need to store all of this, transmit it, and upload it to networks. And in some distant year, it doesn't really matter which. This technology underwent changes. A smart codec appeared. The codec was named H.264+. What changed in it? Thanks to higher equipment performance, it was possible to primarily reduce the noise around the image. That is, in this case, the person was rendered more accurately, without transmitting the background around the person. That's the first thing. Secondly, a specific prediction algorithm was activated, where the reference frame was not transmitted once per second, but could be shifted in time. It might not be transmitted for 2, 3, or 4 seconds if the background didn't change significantly. And each bit change was made relative to the previous frame instead of the reference frame. Thus, we managed to reduce the data volume by 70% on some scenes compared to the H.264 codec, which is generally good. The next big step in development was the H.265 codec. It is very similar to the H.264 Plus codec. It also uses prediction and rendering relative to one frame, but the quantization has changed. Let's not delve too deeply into this process. The most important thing is that we achieved additional data volume savings. But since we saw that the change from the simplest codec was moving towards a more complex one, and the mathematical model was constantly changing, each time the system essentially needs to reconstruct the image by redrawing and adding, and when we want to display all this on the screen, it requires a huge amount of computational power. Therefore, for example, at the dawn of the H.265 codec's emergence, many faced such a problem. Let's say they had a computer capable of recording 16 cameras in the H.264 codec. There was some program installed, and then the cameras at the site were updated, and the person installed 16 cameras. But now in the H.265 codec. And such a computer could not handle such a data stream, even though both were 2 megapixel, and the frame rate was the same. But due to the fact that the H.265 codec has a more demanding architecture in terms of hardware and resources, it's not equivalent. That is, it wasn't possible to replace it like that. What next? You might ask? Indeed, with the H.265 codec, if we try to illustrate this as a kind of timeline, yes, we had MJPEG. It had then ASH 264th plus, then approximately 265th plus. In total, what about now? Logically, you would say H.266 codec and you would be right. The H.266 codec is currently being developed. I won't delve into its features. I can only say one thing. It will require even greater performance from both the camera itself and the recording device. But we will once again achieve data savings. All of this is driven by the increase in camera resolution and the desire to record more and more and more. By the way, for simplicity, the abbreviation MJPEG is used, and similar abbreviations exist for codecs. For H.265, it's called HEVC. H.264 is abbreviated as VC. This is for convenience. Of course, it's easier for us to refer to them as H.264, H.265, H.266. Thus, we achieved a smaller data volume. And approximately, we did not lose quality. There was always a problem in courts with such video, because by law, there should not be any changes in the frame. And in the 2000s, some courts might not accept, for example, video recordings from cameras recorded in the H.264 codec, which was strange, but that was the law. Now this problem no longer exists. What would I like to say about codecs in general? Codecs allow us to increase the number of cameras, expand the archive, which is what we want. And this race will always continue. Hard drive manufacturers will strive to release models with greater and greater capacity, but they can't keep up with the volume of data that we generate and want to record. Therefore, we rely only on codecs that reduce data volume and on hard drive manufacturers who try to increase it. But I think that probably every 3, 4, 5 years, well, probably every 3 years, a fundamentally new codec will emerge that will significantly reduce data volume, just as our video surveillance market is currently growing. That's all from us. I tried to briefly explain how codecs work. I hope you enjoyed it. Write in the comments what you think about this and what you would like to learn in a similar animation format. I will try to make it. Now we are going to make several similar videos, educational ones for our staff, for managers. Well, we will post something for you. Write to me, I would be very happy. Bye.